Welcome to the class of thermodynamic. 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 Thermodynamics is the science of energy conversion and its effects on the property of the system. If we will see the thermodynamic, the weightage of the thermodynamic in the mechanical engineering for the GATE exam is approximate 13 to 15 marks every year. In thermodynamic, we will discuss the basic concept of the thermodynamic as well as applied thermodynamic and the basic aim of thermodynamic is to convert the inorganized form, that is heat, into organized form of energy, that is work, in an efficient manner. We will see here first of all system. Your system is anything in the space upon which your study is concentrate or focused. It means it is the region in space upon which the study is focused. And if we will see the surrounding, anything external to the system is known as surrounding. If we will consider it as a system, then anything external to the system is an surrounding. Then boundary. If we will consider it as a system and it as a surrounding, then a separation line between the system and surrounding is known as boundary. It means the separation line between the system and surrounding is known as boundary. If we take an example of a room, these four are the boundary of the room which are completely rigid. This is a system and these are the boundaries. In this one we will see the boundary are real as well as your boundaries are rigid. But if we will consider the second example of a flow in which the fluid is flowing, and we will just cut the boundaries for study the fluid flow. This 1 and this is 2 section. Then we will see in original there is no boundary of the system, but we are just imaging the boundary. And again we just want to change the section. Your 1 can be replaced by 1 dense. It means your boundary may be rigid, real, may be imaginary or flexible. It means your boundary may be real or imaginary, and it may be real or imaginary, or it may be flexible and rigid. So the next portion is your universe. The combination of the system and surrounding is known as universe. The combination of the system plus surrounding is your universe. And the next is the classification of the system. What are the classification of the system? We will see the classification or type of the system. That means types of the system. There are three types of system. First one, open, closed and isolated system. If we will see the behavior and type of system, first of all we will see the system as a closed system in which mass transfer is not possible, but energy transfer in the closed system is possible. If we will see the example of the closed system is a piston, cylinder without valve, we will consider as a closed system. Again we will see the open system. Your open system is the system in which mass can be transferred as well as energy can be transferred. Example, turbine, compressor, and most of the practical example or practical application or practical system are the example of open system. And then isolated system. No mass transfer is possible, no energy transfer is possible, and its example is universe. The next portion after the system we will see After the system, the next portion we will see the properties of the system. Properties of the system. Any measurable characteristics of the system is known as property of the system. Property of the system. Then type of property. Type of property. There are two type of property. First is intensive property. Intensive property. And in intensive property, the these properties are independent from mass or size. Example: pressure, temperature, etc. Second is extensive property. Extensive property. These properties depend upon mass or size. Example: volume, energy, entropy, etc. If we will take an example of a system, the mass of the system is m, volume of the system is V, and temperature of the system is T, and pressure of the system is P. And just we have divided a complete system into two equally parts. Then we will see the mass is divided into two equal parts, volume is divided into two equal parts, but the temperature and pressure of both the part is same. Temperature is T and pressure is P. In this example we can see in both the case two property of the system are same after changing the mass or the size, that is your temperature as well as your pressure, but the volume with respect to mass is divided into two parts or has been divided into two equal parts. It means you can say in this example it is clear volume is extensive property and pressure, temperature are intensive property. I'll write a star point here. All specific properties properties are intensive properties. Intensive properties. For an example, let's consider energy is an extensive property. Extensive property. Energy is an extensive property. What specific energy, that is your E upon m, its unit is kilojoule per kg, is your intensive property. Intensive property. Again you will see enthalpy, that is your capital H, is extensive property. Extensive property, but specific enthalpy, that is your small h, that is capital H upon m, its unit is kilojoule per kg, is your intensive property. 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 Next we will further move state of a system. The state of a system. The condition of a system at any instant. Condition of a system at any instant is known as state of a system. As long as state is fixed, property remains constant. For an example, at any state 1, the coordinate of a system is pressure P1 and volume V1. Until unless your state not change, the pressure as well as volume of the system does not change. It means state define the property of the system. It means you can say the property is dependent on the state or a point. So I'll give here a star point. So all the properties are, I'll highlight this one, all the properties are point function. And again, all the point function are given by exact differential. So all the property all the properties have exact differential. Let's consider an example. I move from 1 to 2, 1 to 2, and again I move from 1 to 2 by the path A and by the path B. We will see the property of point 2 are P2 and V2. In this example we have seen the path has been changed, but the property of the point 1 and point 2 does not change. It means simply you can say the property is always a point function that will never depend upon the path. And then your process, a change of the state, a change of state is known as process. In the previous figure you have seen the path A change the state from 1 to state 2. So it is called as a process. Your process. Now we will study the types of process. First process may be reversible process, or process may be irreversible process. First of all, we will study the reversible process. Reversible process. A process is said to be reversible process if when path is reversed, it will follow the same path, it will follow the same path, as former without leaving any effect on the system and surrounding. For example, we will consider a path 1 to 2. It will follow a path A. When the direction is reversed, first of all it will follow the same path, means 2A1, but it should not leave any effect on the system as well as on the surrounding. And the reversible process is the most efficient process. Now we will study the irreversible process. Friction is main reason for the irreversibility. irreversibility. Then quasi-static process. Quasi-static process. If we will take an example of a system piston cylinder arrangement, you have two options and you want to change the state 1 to 2. This is your state 1 and this is your state 2. You have two options. First of all, you can lift the weight. You can lift the weight in a single pass and directly your state 1 will reach to the state 2. And the second option you have, you can lift the small portion of the weight and then system go to 1 to second position, and after that you can change the weight from the system for a small portion. Then it means you can understand the quasi means almost and static means stoppable. If you will consider the second option, in which you are just lifting the weight one by one, then you will see your system will follow number of equilibrium state. If you will see the condition of the system on the PV diagram, first of all that is your position 1 and this one the state 2. If you will just lift the weight 1, you will see your system cover something here, new position, that is your A. Again it will go to B, again it will go to C, again it will go to D, and so on. So it will follow the number of equilibrium state. So if you will meet the system the number of state, then the system is called as undergoing a quasi-static process. It means you can say a process which is carried out in a very slow manner, is called as quasi-static process. A frictionless quasi-static process is known as reversible process. Then the thermodynamic cycle. Thermodynamic cycle. A system is said to have undergoes a cycle if after passing number of process it return to its initial state. It means for a closed cycle cycle initial and final states are same, so there is no change of property in a closed cycle. That is an important point. I'll just highlight this point. There is no change in a closed cycle. That is a very important point. This is some basic concepts of the thermodynamic. Now we will study the thermodynamic equilibrium. Equilibrium. A system is said to be in thermodynamic equilibrium if it is, first one, it follow the thermal equilibrium. Thermal equilibrium, it means temperature is same in every portion of system. Second one, I'll say mechanical equilibrium. Mechanical equilibrium, there is no unbalanced force in the system. Unbalanced force in the system is said to be, the next portion is chemical equilibrium. Chemical equilibrium, if there is no chemical reaction in the system, chemical reaction in the system is called as a chemical equilibrium. If a system follow all these three equilibrium condition, a system is said to be in the thermodynamic equilibrium condition. Now we will start with a very important law of thermodynamics, that is your zeroth law of thermodynamics. Zeroth law of thermodynamics. This is very important law of thermodynamics, and with the help of this law, the measurement of the temperature is possible. Let's see what is your zeroth law. Zeroth law states that if body A is in thermal equilibrium with body V, and body V is in thermal equilibrium equilibrium with body C, then body A and C will be in thermal equilibrium. If this is a body A and it is in thermal equilibrium with body B, and again body B is in thermal equilibrium with body C, then A and C, or you can say the temperature of A and temperature of C will be the same, or in other words you can say the body A will be in thermal equilibrium with body C. Body C. In zeroth law of thermodynamics, in zeroth law of thermodynamics, one body is considered as a thermometer for measurement of temperature. For measurement of temperature. And the main application of zeroth law of thermodynamics, application of zeroth law is temperature measurement, and all the thermometer works on thermometric principle. We will see what is this principle. In this principle, or this principle states that the property will change with respect to temperature are measured first, and then temperature is calculated. And these properties are called as thermometric property. All the thermometric property are the property which change with respect to temperature. And on the basis of this thermometric property, we will divide our thermometer in number of types. That means types of thermometer. Your first thermometer is resistance thermometer or thermistor resistance thermometer or thermistor. This type of thermometer thermometers works on Wheatstone bridge. The resistance change as the temperature change. So in thermistor, resistance play an important role of thermometric property. So we will see in the resistance thermometer or thermistor, resistance is known as thermometric property. Thermometric property, it means in this one, first of all we will measure the resistance, we change with respect to temperature, and after that with the help of this resistance we will just calculate our temperature. Second is thermocouple. The thermocouple is based on thermocouple is based on Seebeck effect. Seebeck effect, which state that when two dissimilar metal are joined having different temperature difference, it will create a voltage. It means the effect of temperature difference is generation of EMF, that is your induced magnetic electromagnetic force. So in this case EMF plays a role of thermometric property. That means in thermocouple, induced EMF electromagnetic force is known as thermometric property. And third is constant gas constant volume gas thermometer. Constant volume gas, in this pressure change with respect to temperature. So constant volume gas thermometer pressure play an important role of thermometric property. And the fourth one is constant pressure gas thermometer. In this one, volume play an important role of thermometric property. And the last type of the thermometer, that is very important type, which is more used in the practical application, that is the measurement, that is the main application of this instrument. Or the last type, that is your Hg in glass or mercury in glass thermometer. The length change with respect to the length change with respect to temperature. So in this type of thermometer, length play an important role of thermometric property. Thermometric property. If you have checked the practical application of Hg in glass thermometer, you have seen most of the time for the measurement of the fever, when you go to the doctor, he will check the level of Hg. He will never check the temperature. He will only check the length change with respect to temperature, and with respect to change of the length he will calculate the temperature, and after that it is calculated what is the temperature of your body. This is the main application of the zeroth law of thermodynamic. In this way your basic concept of the thermodynamic has been completed. It means you can see, if you are clear with these basic concept of the thermodynamic, easily you will be able to understand the next portion of the thermodynamic, that will be covered in that will be covered. For example, first law of thermodynamic, work, heat, second law of thermodynamic, and entropy, etc. So this portion of the thermodynamic is very important, because it is the basic concept of the thermodynamic. Thank you, class.